Okay, so Math 3 notes, Unit 3, coterminal angles. We're going to talk about what a coterminal angle is. And we're finally going to get to evaluating trig functions for angles without a calculator. Just to review some of the key things we talked about yesterday, we talked about the standard position of an angle. And we said that the vertex of that angle is always going to be at the origin at 0, 0. One ray is going to be on the positive x-axis. That's your starting point. That's 0 degrees. And then that's called the initial side. And then the other ray is the terminal side. That's where the terminal meaning where it stops. Okay, and that's where your angle is pointed at. The measure of the angle in standard position is the amount of rotation. And which way do we go if it's a positive angle? We rotate counterclockwise, right? And that's what this is saying here. If it's a positive angle, like positive 120, we're rotating counterclockwise from the positive x direction. If it's clockwise, we're going in the negative direction. So we saw that yesterday. What we didn't talk about yet is this right here. Two angles in standard position are called coterminal. Okay, they share the same ending side if they have the same terminal side. So we started to see that yesterday as we labeled. We said, okay, 0 degrees, 90 degrees, 180, 270. So that was one time around. And then we keep going and we say, well, at the same place as 0 degrees, we also put like a 360. And then if we counted 90 again, we got 450 degrees at the same spot that 90 was. So they're both pointed at in the same direction, but there's more than one angle that represents that position. Okay. And so we call those coterminal angles. So 450 and 90 would be a coterminal angle. And what do you notice about all coterminal angles? Well, or at least these. What's the difference between them? Or if I get another one over here. If you subtract any of these right here, the difference is a full circle, 360. So if I'm pointed at a specific direction, say this angle is theta. We have no idea what it is. Say it's theta though, and I want to find another angle that's pointed in the same direction. I can go around the 360 degrees, end up back at the same spot, and so whatever theta was, I'd add 362, and I'd get another coterminal angle. Or I could go around the circle twice and add 362 times. Or I can go backwards. I can go in the negative direction and subtract 360. So as long as you're going a full circle one direction or the other, you end up back at the same point, and we call those coterminal angles. So if 100 degrees is one of the angles we're looking at, what would be coterminal with 100 degrees? 100 degrees would be in quadrant 2. So if I go a full circle from 100, so if I add 360 to that, I get 460 degrees. Okay. So that's a positive coterminal angle. What if I want a negative coterminal angle for 100 degrees? You could start 100 and go the other direction, this way. And so that's the negative direction, so we can take 100 and subtract 360 from it and get negative 260 degrees. So 100 degrees, 460 degrees, and negative 260 degrees all are at that same exact location. They're not the same number, but they all share the same side, so they're all called coterminal angles. Okay, so for negative 400 degrees, find one positive and one negative coterminal angle. All right, Kale, what'd you get for a positive coterminal angle? Yeah. How'd you get it? Okay, so if we have negative 400 and we add 360 to that, we're moving in the positive direction one circle, and that comes out to be what? Negative 40. So we weren't looking for it, but we found another coterminal negative angle, right? And then we take that negative 40, we can add 360 again. So we're going from the same location, just going around the circle one more time, and we get 320. All right. So there's a negative coterminal angle and a positive coterminal angle. Are there other positive and negative coterminal angles with this angle? Or are those the only two? What do you think, Jake? So if I'm at negative 40, we know is about right here. So this position's at negative 40. Also positive 320s here. Also negative 400s here. Are those the only ones? No, there's a lot more. There's an infinite amount, right? So we could take negative 400 and add another negative 360 to it, and then keep adding negative 360, and so those are not the only ones. There's a whole bunch of other ones as well. Just as long as you have that, I want you guys to know that. Okay. A reference angle. Key thing, we did this yesterday. It's the smallest angle that has been made from the terminal side to the x-axis. What else do you know about a reference angle that we talked about, besides being the smallest angle? How small does it have to be? It has to be acute. Can it be negative or does it have to be positive? It has to stay positive, okay? And make sure you're always going to the x-axis. It's stated here again. Never go to the y-axis. So let's take a look at a problem here. So here we're asked to sketch the angle in standard position. We did that yesterday. Okay. And then identify the quadrant in which the terminating ray lies. We did that yesterday as well. Identify the reference angle. We did that as well. But then here's what we didn't do, part D. Identify the sine, cosine, and tangent ratio for each. Okay, so this is going to be new to us. So 150 degrees, what quadrant is that going to be in? It's between 90 and 180. So right here. So quadrant 2. What's our reference angle going to be? It's the difference between 150 and 180, always to the from the terminal side to the x-axis, 30 degrees, right in there. Okay. All right, once you have that reference angle, draw a triangle from that terminal side, connect that terminal side to your x-axis. And if I'm going to ask you to find the sine, cosine, or tangent, the triangle that you're going to end up with is either going to be the 30, 60, 90 or the 45, 45, 90. Because those are the only two triangles we're responsible for memorizing. So here we have a 30, 60, 90. So the one I asked you to memorize has a length of what across from 30? 1. So across from 30 is the smallest side, 1. The hypotenuse is 2, and across from 60 is square root of 3. Okay. Because we're in quadrant 2, we need to keep track of what should be positive, what should be negative. So the base of your triangle is your x-coordinate. Should it be positive or negative? Negative in quadrant 2. And then the height of this triangle, thank you. Thank you very much. The height of the triangle's 1. Should it be positive or negative? Positive. Okay. And so we have our x and y coordinates. Also, 30 is our reference angle, so y is the opposite side. X is your adjacent side. And 2 is going to be your hypotenuse. So once you have that, then we can find the sine, cosine, and tangent. Now, we're not finding the sine, cosine, and tangent of 30 degrees. This is something that's different. We're actually finding the sine, cosine, and tangent of 150 degrees. There's this relationship between 150 degrees and 30 degrees. They're going to have the same sine, cosine, and tangent, except for one may have a negative sign, one may not, right? 150 degrees is like having a 30-degree angle in quadrant 2, which gives us an x value of a negative, so that's what throws it in. If we had 30 degrees in quadrant 1, everything would be positive. So that's the only difference. So there's this special relationship between 150 and its reference angle. So when we fill this out, we're going to put sine of 150 degrees, not 30. But when we find the sine of 150, we're looking at this triangle with 30 as our reference angle. Okay. So sine is opposite over hypotenuse. And opposite is 1, hypotenuse is 2. So sine of 150 is positive 1/2. Cosine is your adjacent over hypotenuse, and it's of 150 degrees. And in this picture, adjacent is negative root 3, hypotenuse is 2. And I said it, but I didn't write it, so it should be root 3, not root 2. And then the tangent of 150 degrees would be what? Opposite over adjacent, which would be 1 over negative root 3. And multiply top and bottom by the square root of 3 on this one. And so you end up with negative root 3 over 3 for the tangent. No, you just multiply. You want to rationalize your denominator. So you could. You'll end up with the same thing though. Yeah. Okay. So that's the process. This last step, part D, is the new part for us. Let's try it again with negative 120 degrees. Go ahead and find negative 120 degrees, find its reference angle, find the quadrant it's in, because that's what you did for homework. Okay, Seth, where's negative 120? What quadrant? Quadrant 3. Because this is 0, we're going the negative direction, negative 90, negative 180, so negative 120, right here. And Seth, what'd you get for the reference angle? 60, good, because you're subtracting negative 120 and 180. You're getting the positive difference between those two. Right in here, 60 degrees. Okay. And your hope, it's either going to be 30, 60, or 45 for us. Okay, when we're finding the sine, cosine, tangent. And so we make a right triangle by connecting that terminal side to the x-axis always. And then fill out the side lengths. And respect the quadrant you're in. Okay, so across from 60 is what length? Root 3. But that's your y coordinate. And so should it be positive or negative? Negative. And then across from 30 is what length? 1. Should it be positive or negative? negative because we're in quadrant 3. Both x and y are negative here. And then this third side is a tea kettle of boiling water on top of Mount Everest, right? This third side is a tea kettle of boiling water on top of Mount Everest. Or, in other words, a high pot in use. And that should be 2. It's a high pot in use. A tea kettle of boiling water on top of Mount Everest. All right. That's too much for you guys. All right. Okay. Still processing there. Okay. So the x values in this case is x equals -1. Is that the adjacent side or opposite side? Adjacent side. This is your opposite side. This is your hypotenuse. So our reference angle was 60 degrees. And what angle am I going to use here for sine of what angle? No. Negative 120. Okay. Not 60, negative 120, because that is the angle that put us into quadrant 3. Okay. If you put 60, that would be in quadrant 1, and you'd only have positive x values and positive y values. But because we're in quadrant 3, that's coming from the negative 120 degrees. And so sine is opposite over hypotenuse. So negative root 3 over 2. Cosine of negative 120 be adjacent over hypotenuse. So negative 1 over root 2. Sorry, negative 1 over 2. And tangent of negative 120 is opposite over adjacent. So negative root 3 over 1, which reduces to negative root 3. Okay. And so now you guys are able to find the sine, cosine, and tangent of angles that normally you wouldn't be able to find. And they're just coming from the 30, 60, 90 right triangle. So see if you can make it all the way through with 405 degrees. See if you can find the sine, cosine, and tangent of 405 degrees without a calculator. Okay, 405 degrees. Emily, where's 405 degrees? Quadrant 1? Okay, so we're going around this way. Got to go more than one circle, right? So this is 180, 270, 360, still haven't gone far enough. And then we've gone too far at this location. We got 450 degrees. So yes, it's in quadrant 1. Okay, so 405 right here. And then, Emily, what'd you get for the reference angle? How'd you do that? How'd you get 45? What'd you do? Good. So if you subtract 405, which is our terminal side, with the angle on the x-axis, don't choose 0 because you want to get something that's acute, smaller than 90. You end up with 45 degrees. Okay. And so then you draw your right triangle from the terminal side, connect the terminal side to the x-axis, got your 45, 45, 90. And so in quadrant 1, your x value is positive, your y value is positive, and hypotenuse is always positive no matter what quadrant you're in. And what is the hypotenuse in this case? Root 2. Okay. So our reference angle is 45 degrees. For the sine, cosine, and tangent, what angle are we using here? 405. Good. We're not going after 45, we're going after 405. So put the 0 between the 4 and the 5. And this is degrees as well. Okay. Jacqueline, what'd you get for the sine of 405? Okay. Before you got root 2 over 2, what'd you get first? 1 over the square root 2. Good. And same for cosine, right? And then we can, because the square root's in the denominator, you multiply top and bottom by root 2, and you get root 2 over 2. And this one, you get the same work. And Jacqueline, what'd you get for tangent? Good. Okay. So that's sine, cosine, and tangent of 405 degrees. $330, did you guys go that far? All right, let's do it together then. Abby, where's 330? Yeah, what quadrant? 4, good. 0, 90, 180, 270, 330. I meant 360, yeah. Looking for 330. So 330 somewhere over here in quadrant 4. And so Abby, what reference angle does that give us? Good. So if you subtract, find the positive difference between 360 and 330, you get 30 degrees. So we're looking at this right triangle here. And we want to put in the side lengths to this right triangle. Gio, what side length should I put on here? Where do I put them? And should they be negative or positive? Okay, so what for the x? What do I put? What number? X is across from 60, so it should be square root 3. And then the y should be what? That one's going to be one positive or negative? Negative 1. Okay. And then the hypotenuse, and hypotenuse is always 2. I mean, always positive. Not always 2, but always positive. Okay, good. And then, Gio, the x value, is that the opposite side or the adjacent side or the hypotenuse? Good. And so we're looking for the sine, cosine, and tangent of 330 degrees. And you're doing a good job, Gio, so keep going. Sine, cosine, tangent, what do we get? It's all right. We could do it right now. For the sine, what'd you get? And how do you find the sine? Sine is equal to what over what? Opposite over hypotenuse. So what would it be? Good job. And the cosine? Adjacent over hypotenuse, which is square root of 3 over 2. And the tangent, opposite over adjacent. Careful. It's negative 1 over square root of 3. And so when you simplify that, you end up with it being negative. So negative square root of 3 over 3. Okay, good. So that's a little bit on finding sine, cosine, and tangent of things that we're not used to finding. So angles that are not necessarily acute angles. These next angles are what we call quadrantal angles because what happens is they land on the x-axis or the y-axis, and you don't have a reference angle, you don't have a triangle that you can draw. And so we need another way, and it's actually a pretty easy way to come up with the sine, cosine, and tangent on these. To remind you, yesterday and the day before, we had a couple problems where we were looking for an xy coordinate. right? In particular, this xy coordinate here. And we said there's a relationship between your xy coordinate and the side lengths of a triangle. We said, okay, the base of that triangle is your x coordinate, and the height of that triangle is the y coordinate. And the reference angle comes from the point at 0, 0. And so the y value is always your opposite side, and your x value is always the adjacent side. And then you have your hypotenuse here, right? Now, if your hypotenuse equals 1, something nice happens. What would the sine of, if this is theta, what would the sine of theta equal? If your hypotenuse is 1. What would, in this picture, what's the sine of theta equal to? What's that? Y over 1, right, which is just y. The opposite over hypotenuse ends up being y. And the cosine of theta ends up being what? Adjacent over hypotenuse, x over 1, so just your x value. And careful, this only happens when your hypotenuse equals 1. Right? Because if your hypotenuse wasn't 1, it'd be y over whatever that hypotenuse is, or x over whatever the hypotenuse is. And what would the tangent be? Y over x, opposite over hypotenuse. Okay. So if I end up with a point, so if I end up finding, like, if I want to know the sine of 90 degrees, so we're looking at 90 degrees. If I'm working with a hypotenuse of 1, and you could picture this, the distance from here, the hypotenuse is the distance from 0, 0 to the point you're moving around, right? So 90 degrees, if I go a distance of 1 from 0, 0 up towards 90 degrees, what's that coordinate? That distance is 1. That coordinate is going to be 0, 1. And so we know the x value and we know the y value. And so we can use this idea to find the sine, cosine, and tangent of 90 degrees. So I'd say, okay, well then the sine of 90 is my y value, which is 1. The cosine of 90 is my x value, which is 0. And the tangent of 90 is y over x, which would be 1 divided by 0. And what happens when you divide by 0? Undefined. We've talked about that quite a bit in this class. So this is undefined. Okay. And so whenever you're working with an angle that's either on the x-axis or the y-axis, this is your key. This is what you're going to use to find the sine, cosine, and tangent. Go a distance of 1 away from 0, 0, find that coordinate, and plug it into this to find it. So that's what we're going to do on these. Okay. So negative 90 degrees is 0. Going negative 90 right here. We end up on the y-axis. Go a distance of 1 down from 0, 0. And what's that coordinate going to be? 0, negative 1. Where this is your x, this is your y. And remember, sine is your y value. Cosine is your x value. Tangent is y over x. And then you just plug it in. Negative 1, 0, negative 1 over 0. And whenever 0 is in the denominator, you say it's undefined. Okay. I want you to try that for the next 3 problems. They work the same exact way. Okay, 180 degrees. Is that on the positive x-axis, the negative x-axis, the positive y-axis, or the negative y-axis? Zoe, where is that? Negative x-axis. So positive 180 and negative 180 end up here. And so from 0, 0, we move 1 to the left, a distance of 1. And what would that coordinate be? Comma 0. Good. And so what'd you get for sine? So sine's your y, which is 0. Cosine is your x. And how about the tangent? Good, 0. Because it's y over x, and in this case you get 0 over -1. That's not undefined, that's just equal to 0. Whenever 0 is in your numerator, you get 0 for your result there. Okay. Thank you, Zoe. 360 degrees. Christian, where's that? Positive x-axis, negative x-axis, positive y, or negative y? Okay, positive x-axis. And what is the coordinate of that point? Sine? Good. Cosine? And tangent? Good job. And then the last one, negative 270 degrees. Haley, where's that located? At 0, 1, right here. And what is the sine, cosine, and tangent of that one? Good. All right. So that they're not too hard to handle. You just need to know how to handle them. You got to remember which one's the sine, which one's the cosine, how do you figure out that tangent. If you got that down, these are pretty simple to do. Okay. This last part here, we want to identify all the quadrants where the terminating ray for theta can lie so that the equation's true. So you're not being asked what theta is. We're asked where theta could be. Okay. So all you have to pay attention to in this, like on this first statement here, is this. The cosine of theta is negative. That's all you take from that. You don't care about the 5 over 12. You're just looking at, is it positive or negative? Because that's going to indicate, well, where could it be? Okay. And what's going to be most helpful for us here is if we take what we just learned in the past part with this. So let's assume our hypotenuse is 1, because we can make our hypotenuse length whatever we want. And if it is, then our cosine is which value? What did we say up here? Cosine is your x coordinate. So now the question is, in which quadrants is our x coordinate negative? So this is quadrant 1, 2, 3, and 4. We'll just think about our x-axis. X-axis is positive on this side, negative on this side, right? And so 2 and 3 would be our answer to this problem. So it says identify the quadrants, so our answer would be quadrants 2 and 3. Okay. So for the next one, here, what we want to take from this is that the sine, which our sine is our x or our y value. The y value is, and then just look at what's happening here, positive or negative, right? And so those are the only options, right? If you go to each quadrant, your y value is either going to be positive or negative. So what quadrants could this be in? All of them. So whenever you have that plus or minus sign, your answer is going to be all of them because those are your only options. So we're going to say quadrants 1 through 4. Tangent is the one you got to think a little bit more on. So tangent is not just x, it's not just y, it's a combination of both of them. And from above, what do we say? Tangent is what over what? Y over x, opposite over adjacent. And this is, don't worry about the 4/3, just worry, is it positive or negative? So this is positive. Okay. So let's think a little bit here. If you have a fraction that's positive, what does that tell you about the two numbers in your fraction? So they're either both positive. Is there another case? Or they could both be negative, right? Because a positive divided by positive is positive, and a negative divided by negative is positive. But you can't have one is positive and one's negative, right? And so then you think about your quadrants. Well, if both of them are positive, where are you? Quadrant 1, right? If this is where x and y are both positive. If both are negative, where are you? Quadrant 3. So those are the two spots where your tangent is positive. Okay. All right, homework is to do all the problems in worksheet 3 from unit 8.